Welcome to DI API Fundamentals, Mastering the SAP Business One Data Layer. This video provides a comprehensive guide for developers and consultants implementing enterprise add-ons with the SAP Business One SDK. The Data Interface API is the official gateway between your add-on and SAP Business One's core logic. It operates through a layered architecture, ensuring data integrity and providing programmatic control over business entities. DI API is crucial because it enforces business rules, ensuring data integrity and system consistency. It handles automatic validations, approval workflows, and security checks, which direct database access would bypass. The core of the connection is the company object, a stateful session handler, object factory, and transaction coordinator. Remember, for thread safety, each thread must maintain its own company object instance. Connecting requires setting precise parameters like the server address, the company DB name, and the valid username and password. The DB server type specifies the database platform in use. The connect method attempts to establish an authenticated session. It performs the connection attempt and session initialization. Always verify the return value, as a non-zero result indicates a failure that requires error investigation using GetLastError. Business objects represent SAP B1's core entities, mapped to specific tables and governed by business logic. The BoObjectTypes enumeration provides type-safe access to entities like business partners, orders, and items. Business objects automatically manage underlying table relationships. To create a business object instance, use the getBusinessObject factory method. This ensures proper initialization and transaction coordination. After retrieval, cast the object and assign strongly typed property values based on SAP's data model. The object lifecycle includes creation via getBusinessObject, setting properties, validation by SAP's business rules, and persistence to the database via transaction. This structured process maintains crucial data integrity. DI API supports standard CRUD operations. Add creates new records, GetByKey retrieves records for reading, update persists modifications after revalidation, and remove deletes records while respecting referential integrity. The add method manages underlying SQL insert statements across relevant tables. It performs necessary validation and handles document numbering automatically. The script demonstrates obtaining the object, setting properties, calling add, and handling potential errors. GetByKey retrieves data using the primary key, populating the object with data from all related tables. Always verify the Boolean return value. It is sufficient for fetching only the required data. To modify records, first, retrieve the current state with GetByKey. Then, modify the desired properties and call update. The DI API only generates update statements for modified columns, and it includes optimistic concurrency control. The remove operation deletes a record, but it enforces referential integrity. Deletion will fail if dependent documents exist, such as open invoices for a business partner. Check for related documents before attempting removal. Helper methods like getNewObjectKey are vital when creating related objects. Call this method immediately after add to retrieve the generated primary key for maintaining foreign key relationships to child objects. The BoRecordset object provides direct SQL access. Use it judiciously for complex joins, aggregations, or read-only data that doesn't map to business objects. Never use it for data modification like insert or update. Always implement explicit error checking. DI API methods return integer result codes where 0 is success. Use GetLastError immediately after a non-zero result to retrieve the detailed error code and descriptive message. This is crucial for logging. Database transactions ensure data consistency across multiple operations. Use start transaction to begin a block. Perform all add or update calls, check results, and then call end transaction to commit or roll back all changes if any step failed. SAP Business One supports user-defined fields or UDFs, accessed via the userfields.fields collection. User-defined tables or UDTs are custom tables. Access UDT data using the Recordset object and direct SQL queries. The best practices include using business object methods, always checking return codes, using transactions for atomicity, and releasing COM objects to prevent memory leaks. Also, avoid hard-coding values and implement caching strategies. SAP documents have a header and line structure. The header holds general metadata, while lines contain individual transactional details. The DI API represents these as separate objects within the document hierarchy. To work with document lines, you populate the properties on the lines object, and then call lines.add to append the row. The API automatically handles line numbering for you. When reading existing document lines, iterate through the collection count. For each iteration, call setCurrentLine index before accessing line properties. Failing to set the current line results in repeated data or errors. Proper COM memory management is essential to prevent application crashes. Always call marshal.release COM object on every instantiated DI API object. Set the object reference to null and use a try finally block for reliable cleanup. The DI API is not thread safe, requiring one company connection per thread. Use connection pooling to manage concurrent sessions efficiently. To improve performance, batch operations, and minimize round trips to the server, use the correct enumerations for Boolean fields, such as boyas noenum. For date fields, use datetime objects. Adhering to these types ensures compatibility and data integrity during operations. For production readiness, always verify record existence before modifying it. Implement logging, and use transactions to ensure data consistency. Use GetLastError code for detailed error diagnostics. Performance optimization techniques include batching multiple operations in single transactions and filtering data server-side using Dockery. For high volume, implement connection pooling to reuse company objects efficiently. Testing in a development environment is critical. Use unit tests, detailed logging of inputs and outputs, and test with different user permissions. Debugging relies on GetLastError code and DI API tracing. Avoid common pitfalls like forgetting set current line when iterating lines, ignoring method return codes, failing to release COM objects, hard-coding field names, and assuming master data exists. So now you've understood how the DI API works, how we connect to SAP Business One, how we interact with business objects, and how data is created, updated, and managed safely using SAP's business logic. But here's the thing. DI API works behind the scenes. It handles the data layer, right finger. What about the user interface? How do we customize SAP screens, add buttons, forms, and menus, capture user actions, and trigger our logic? That's where the UI API comes in. In the next video, we'll move from back-end to front-end and start building real interactive SAP Business One add-ons. We'll cover UI API architecture, forms and items, events and user interaction. So make sure to subscribe and stay tuned. Let's continue the journey rocket.